Formula for area between a curve and the y-axis. In this module, you will learn how to derive the formula for the area enclosed between a graph of a continuous function and the y-axis in a given closed interval. Suppose we have a continuous curve that represents a function, say x equal to f of y, defined in the closed interval AB. We need to find the area enclosed between this curve, the horizontal lines y equal to A and y equal to B, and the y-axis. Let us find out how we can find this area. If we mark a small fragment on the y-axis representing the distance delta y, then there is an approximate constant value of the function over this very small change in the value of y. The constant value of the function multiplied by the very small change in the value of y gives the area, say AI, of this thin rectangle. If we create n such rectangles of the same width between A and B on the y-axis, we can think of the approximate area enclosed by the curve and the y-axis in the closed interval AB as the sum of the areas of these rectangles. By representing the area of the rectangles as the product of their respective length and breadth, we get this equation. This further indicates that the approximate area under the curve is the summation of f of yi multiplied by delta y, where I varies from 1 to n. When delta y approaches 0 in all the rectangles, the number of rectangles approaches infinity and the approximate area becomes more exact. This limit of sum is symbolically expressed as definite integral from a to b f of y dy. Here, the integral sign stands for the limit of a sum, and the numbers at its top and bottom specify the interval over which the areas of the rectangles need to be added. F of y is the integrand and dy represents that the variable of integration is y. If we shift the same area to the left side of the y-axis, then the area is represented by the same definite integral, but with an opposite sign. In this module, you have learned that if the area bounded by the continuous curve of a function x equal to f of y, the horizontal lines y equal to A, y equal to B, and the y-axis lies to the right of the y-axis, then the area is equal to a definite integral from a to b f of y dy. If the area bounded by the continuous curve of a function x equal to f of y, the horizontal lines y equal to A, y equal to B, and the y-axis lies to the left of the y-axis, then the area is equal to the negative of the definite integral from a to b f of y dy.